Welcome to the Coinbase Developer Podcast. We originally recorded this episode on x402 about a week ago, but things have changed so much and the graphs are going up and to the right so much that we thought we'd record this cold open. Erik, what is going on with x402?
Well, I think we went viral, as the kids say. It absolutely took off on crypto Twitter over Thursday and kept its momentum over the weekend. And we had this nice, easy to explain 30% week over week compounding growth, and then vertical line.
It's looking pretty good, honestly, for your weekly yearly performance review. That's for sure. I know a bunch of stuff has launched. I saw like x402 scan, a few other products. What are you excited about here?
Utility.
And there you have it, folks. No, that's great. Well, there's a lot going on here. In this episode, you'll hear a technical deep dive into what x402 is and how you as a builder may be able to use it. So please enjoy this episode on x402. Welcome to the Coinbase Developer Podcast, a technical deep dive with top on-chain builders in crypto and beyond. I'm Hugo Kohler, engineering lead at Coinbase Developer Platform.
And I'm Erik Reppel, head of engineering for CDP.
So today's episode is really special because our guest is none other than Erik Reppel himself, head of engineering at CDP. Erik, you're in the hot seat today, and we're talking about a very special protocol called x402, which is the open standard that can make payments as native to the internet as HTTP itself. Maybe tell us a little bit about how you came across it and how you started thinking about it when you wrote the spec for x402.
Yeah. So in addition to my job at CDP, I'm also the author of x402. And x402 really came along from, it's been a thing that I think has been thought about for a very long time. And before rejoining Coinbase, I'd spent a bit of time figuring out like what did I want to work on next, and this is one of the things that I considered. And then actually, while I was interviewing at Coinbase, Brian Armstrong told me that we have like a next bet that's kind of similar to what you're talking about. And so when I joined, I realized I should fund this next bet and see what they're doing. And then I kind of took what they had and rewrote kind of the like implementation of it, and we rebranded it to x402, and it's been out for 6 months now in the wild doing real transactions. And fundamentally it tries to answer the question of how do you transmit value in an internet native way.
That's super exciting. And for context for people listening, the Next Bet program is a very cool part of Coinbase where people are solicited for ideas that get sort of incubated like startups within Coinbase, and this was one of those. So maybe we can start off with a brief history of the internet, just to set a lot of the context for what x402 is about. So when we talk about the internet, and this is very personal to me, inventor of one of the original authors of the www spec, Tim Berners-Lee, is from my hometown of Lexington, Massachusetts. So tell us a little bit about like the progression of the internet from Web 1.0 to Web 2.0.
I had no idea you and Tim Berners-Lee were from the same town. That's cool.
Yeah.
The high technical output from random town in Massachusetts that I've never heard of. The internet is like, it's a really interesting topic because there's a lot of lore. And I think most people understand that the internet was kind of invented at CERN by Tim Berners-Lee, but they don't really know like what actually was part of that. Like what was the thing that they produced? Really what they produced was a set of standards and then what we now call a web browser. It had a different name back then, but they produced a set of standards and then they produced an implementation of those standards. And so what those standards were HTTP, HTML, and then a way to render HTML sent via HTTP, which is the internet browser we know and love today. I remembered it was a www client is what they called it, not a browser at the time. And fundamentally what they did was like they documented here's what needs to go across the network. They had TCP, but TCP is like a very low level protocol. You basically shove bytes down it and they are received at another computer. And so you need to have some agreement of like, okay, how are we going to shove those bytes down the pipe, and what is the format of those bytes, and then what are those bytes going to represent, and then how do we take the things that those bytes represent and then show them to a human instead of a computer?
Makes sense. Those early days, I was probably, I had my first website in 1998. I think I was like 9 or 10 years old. I had this like really cool Pink Panther GIF on my homepage. So those days of like when the browsers were just, or www clients, World Wide Web clients were popping up, were really exciting to me. Maybe we can take a look. By the way, this is going to be pretty familiar to people who are developers, but just so people understand like what HTTP looks like what is HTTP? Maybe Erik, you can talk us through like what we're looking at here.
With HTTP, there's a particular set of bytes that are sent down a TCP pipe, and now there's UDP and all that. Basically, between the connection, computers are connected via TCP or UDP or some underlying socket, and then you're sending very particularly structured data through that connection. And HTTP is the structure of that data. And so in HTTP, you may send a request to a server and say, hey, I want to post to the /users endpoint. I'm adhering to HTTP 1.1. The host that you're trying to access is example.com. The content type is application /xwww forming URL encoded. And then the amount of content to expect from me is 49 bytes. And then a new line, and then the bytes that you're going to receive, that you're going to send to the server. And the server gets that, knows how to process all that string of bytes into something it can programmatically operate on. And then we'll send something that looks like the lower screenshot that is the response, which says, I'm also adhering to HTTP 1.1 200. 200 is a status code, which means everything's okay. And then information that are the headers, like the server, the date, the caching policy, the content type of the response, and then any other data that is going to be returned from the server, and then the body, which is after that new line, which is an HTML string.
Yeah, I mean, I think it's really interesting to consider. We use these terms like client and server very intuitively, but like that derives from like a restaurant, basically, right? You have a client who comes, who asks for stuff, and then the server helps you out and gives you the stuff. So the client sends in a request, which is on the left hand of the side. It's structured in a very particular way, like you said, hypertext transfer protocol. And then the server gets the request and does stuff with it, and returns a response. And so the client is, you can think of as maybe the home side, it's like closer to you, and the server is the cloud, it's some other thing that's connected via this protocol that is doing something on your behalf. It's providing a service, and then it responds with the right-hand side.
It's actually a really interesting artifact of history that they got this right on the first attempt, because back in the day, like back at CERN Labs, every computer was both a client and a server. And now if you look at the modern internet, things are pretty strictly either a server or a client. Like you and I don't run our personal websites on our laptops anymore, but back in the day, if you're a researcher in CERN, your website was run on your computer under your desk, and you would make requests to other servers from that same computer. And so you have like client and server is really just a paradigm of like who is initiating contact. Like the client reaches out to the server responds, but it's not obvious that you're going to get that right if everyone's doing both all the time. And you see other protocols where you're constantly doing both. Like the torrent protocol, for example, you're always seeding and peering, and you're downloading and you're uploading at the same time. And you're kind of intrinsically doing both. And so it's like a very like interesting artifact that they happened to get that right on the first go, because that client server distinction is really what allowed the internet to scale. And that Meta can run thousands of servers, Coinbase can run thousands of servers, Google can run millions of servers, and you can have billions of clients who all get routed to those servers. Whereas if it was more kind of doing both, it would have been more difficult to like have a clear scaling paradigm.
It feels like that sort of derives from kind of Linux and the design of very small processes and piping, and there's an input and there's an output, and you have like interprocess communication where like you might not share memory space, but you want an output of one input of one program, output go in as an input to the next one, and that sort of maps, not quite one to one, but it's pretty similar to the client server idea.
I have a piece of trivia for you, Yuga. Do you know what type of computers they used at CERN when the World Wide Web was being developed?
What type of computer? No, I don't.
So they were actually using Next computers.
Oh, interesting. The company that Steve Jobs ran for a little bit.
Yeah. And so that actually makes total sense because Next is, it's actually the Next computers is what now MacBooks are made out of. And if you program for MacBooks or Mac OS, you'll see NS and ND as like Next data type as like the prefix for like everything. And so you'll have like N integer and everything, and Next integer, Next string, and Next basically ran Linux. And so I think your theory very much holds because they'd be operating in a very Unix paradigm when they were developing these machines and this protocol.
That's fascinating. Okay, so we got a little bit of history of the internet and HTTP, www, how that works, what that looks like, and for a long time, it's we humans that have been using the internet. But it seems like with all this talk of AI coming online, we're kind of on the dawn of a new era. So maybe give us your thoughts on like how the internet works for humans versus what it means when we kind of transition to this phase of AIs coming online.
Whenever you have a new paradigm, you end up with like a new technologies that are going to need to like shepherd that paradigm. And so Web 1, which we just talked about, was really just read on the internet. Web 2 was kind of inspired by, okay, now everyone has computers and you're starting to have like lightweight forms of mobile devices that can interact with the internet. It'd be great if we could write data back from the client to the server. And so you ended up with things like JavaScript and Ajax and JSON being invented to allow computers to write back to the server and not just read data from the server, but tell server, hey, I would like to like send you data, and that the data that I'm sending you is like, it could be a like order to buy Bitcoin, or it could be, requesting an Uber ride or anything else. And that the mobile revolution really kind of relied heavily on Web 2 technology existing because now servers could be more interactive with the devices that were calling them, the clients that were calling them. And this, I think, is a large portion of the success of mobile, is that everything became interactive. And despite it being like web technologies, like your phone uses HTTP to talk to servers as well. Like it's no longer just websites and web pages. These things kind of took over as a canonical way for any two computers to communicate to each other at scale. And so now we have this world where AI is starting to pop up, and you and I use AI every day as part of our jobs to help us code, to help us write docs, everything else. But I think the internet is not yet properly equipped for a world where computers are operating the computers that talk to each other. Currently, just humans operate computers that talk to other computers. And you see that in things like HTML and other forms where there's so much information in HTML. Likely the majority of information in an HTML page is actually geared to how to render the data in a nice way to humans rather than to concisely tell another computer a specific thing. Like an LLM doesn't care about if a font is bolded. It just cares what the font says. And your job actually is like significantly harder if you have to strip out all of those extra tokens that are actually an incumbents and a headwind for the AI to be capable at performing its job.
Makes sense. So because humans have been using the internet and variety of clients exist, whether it's mobile or web browser, and AI agents are not just another type of client in a sense, but they don't need all the bells and whistles that humans need in terms of visual organization, UX, and things like that. So there is a bit of gap there. And so I think the third piece of context regarding X402 is around payments. We've talked about the internet. We've talked about AI agents and how they differ from humans. And I think the third piece of context is this notion of payments within the internet. And I have this nice quote that you've assembled from our very good friend, Mark Andreessen here. Maybe you can tell us a little about this and reflect on it.
Yeah, future guest of the pod. I think the kids call that manifesting. Mark Andreessen was an early pioneer of the internet. He was responsible for the Netscape browser and a bunch of innovation. Fun fact, Mark Andreessen actually originated the image tag. So if you've ever viewed a image on the internet, you can thank Mark. And there's this big long quote, but the main important piece here is, I think the original sin was that we couldn't actually build economics, which is to say money, at the core of the internet. And moral lore, it's not for lack of having tried. I think Mark spent a pretty significant amount of time trying to work with different payment rails to get money movement to work within the Netscape browser. But it's just hard. In fact, working with the financial infrastructure made the task impossible. We tried, we talked to credit card banks. We weren't able to take payments. Microsoft wasn't able to do it. And there's a bunch of reasons for that. Some of them are technological, some of them are not technological. But this is actually one of the reasons why Mark got into crypto, is he tried to solve this problem pre-crypto, and it was hard. And the good news is that now we have these amazing ways of moving value using blockchains, either L1s or fast L2s. And we have things like stablecoins, which mean that the value that you're sending or receiving isn't going to fluctuate a ton and is like in a denomination you're used to. And X402 it's a really old problem, as I mentioned, that we're trying to solve. People have been trying to solve it since the 90s. It's just that now's the time because of the technology. And the artifact of it is back in the 90s when they cemented HTTP 1.1, which is functionally what everything still uses. HTTP 2 is used occasionally, but HTTP 1.1 is really the lingua franca of computer communications, as in everything supports it. They reserved the status code 402. We talked earlier about 200 being the status code for, hey, everything's good, you're okay. HTTP 402 is payment required. And what you're showing on the screen now, you guys, the entire text of the 402 status code in the specification for HTTP 1.1, which just reads, the HTTP 402 payment required status code is reserved for future use. And so what X402 tries to do is it tries to extend this 402 status code into allowing clients and servers to actually transmit value between them and pay each other.
So this is really cool lore because we're reusing the original status code of HTTP 1.1 402, which was supposed to be for payment required. It was a dream deferred. It never actually came to fruition until now. And that is happening in the form of this new protocol that you're leading called X402. So tell us, what is X402?
As with so many standards like HTTP, X402 is simply a way for a server and a client to understand how to send money between them. Ultimately, X402 is a set of data, some shapes that can be consistently communicated and reasoned about by the client and server, a prescription of where those fields should likely go and where to expect that data, and then an optional component to allow servers to abstract away on-chain interactions in case they don't want to operate a wallet or operate an RPC node to a crypto environment. So there's a ton of like little design decisions that are important, but at its simplest form, X402 is like data that's sent between a client and a server that tells them that, hey, you can pay using any number of these mechanisms.
So X402 is a standard or protocol that essentially tells how a client and server should communicate. Maybe we can actually just walk through the flow here of what that looks like. walk us through it. You see the client, you see the server. There's this thing called a facilitator and there's a blockchain. Tell us, client wants to pay the server. How does it work?
This is kind of the typical x402 flow. So a client comes to a server responds with a 402 status code saying, hey, I need you to pay me in order to access this content. And along with that 402 status code, it provides what we call the payment requirements. The payment required status code gets activated into an accompanying piece of data that you return with that 402. And so that payment required response contains one or many methods that the client can select from in order to make the payment. And so let's say they may have USDC on Base, or they may have USDT on Solana, they may have ETH token on Ethereum mainnet. The server tells the client, hey, these are all the different things that I'm willing to accept payment in. And the client says, great, I'm willing to pay you using, let's use USDC on Base as an example, USDC on Base. And they have a common understanding of what it means to accept payment on USDC on Base. And so the client does some work. In the case of USDC on Base, it signs an EIP 3009 transfer with authorization message, and then it includes that signature along with some other important data in a header and remakes the request to the server. So it remakes that get/API. The server can now do steps 5, 6, 7, and 8 itself, or delegate those steps to a facilitator. The facilitator exists to optionally allow the server to abstract away interactions with the blockchain. Because for folks who are new to crypto, that can be difficult. And CDP has a ton of other products that make interacting with blockchains a little easier. It's still new. Most people aren't running nodes and wallets in production as of today. And so what the recommended flow of the facilitator is you call an endpoint/verify, which tells you, hey, am I likely to get paid based on this piece of information? Does this satisfy my payment requirements? Is the signature valid? Does the client actually have funds on chain? And the facilitator will say, yeah, you are likely to get paid. The server will then do work to fulfill the request. So that could be reading from a database, or it could be generating an image, or any other thing that needs to be done in order to fulfill the request. And then it'll call settle on the facilitator. And the facilitator will then submit the transaction to the blockchain. The logic here depends on the token and the blockchain. And then once the transaction is confirmed, it'll tell the server, yep, you have received the funds, you're safe to return to the client. And the server returns to the client the same way it normally would, but with an additional header X payment response that contains the details of the transaction for the client's record keeping. This is, to my knowledge, the first canonical way of expressing a payment in terms of request flow. There's been a lot of attempts at doing things similar. There was a W3C standard around macaroons, but the big unlock here is that because you have open access to stablecoins and anyone in the world can spin up a wallet and send and receive stablecoins on any number of different blockchains, you don't need to go and talk to anybody before you start accepting x402. It's fully permissionless. It's fully open. You can do every part of this diagram without talking to Coinbase, without talking to any other singular actor. Similarly to how you can stand up a web server anywhere in the world, and every other client and every other server is able to talk to your server without there being some central registry or anything else that needs to go on.
So this lays out things very clearly. It's sort of like a two-phase request flow. In the first part, the client requests an API endpoint that they might have to pay for, and the server says you got to pay for it and gives you the details of how to pay for it. Then in the second phase, the client essentially fulfills the instructions that the server just gave it of how it should pay for it by signing a transaction that will eventually get broadcast on the blockchain, passes that to the server. The server can either use a facilitator or verify that itself, then fulfill the API request, and then settle by broadcasting that transaction or user operation onto the blockchain, and then returns success back to the client. So it's a very elegant design. I wanted to switch over to the X402 GitHub. X402 is sort of open source, very open source protocol. Has a lot of stars. I believe one of the most starred repositories that Coinbase has ever provided. And you've mentioned a lot of these principles already. You did mention like base, and I think you may have said USDC, maybe not. But I think one very interesting part about this is that it's chain and token agnostic. So can you talk a little bit about that?
Yeah, I think standards work well when they're a shelling point. And you kind of have to play a game of everyone should be invited to the party, right? Like any token, any chain should be welcome to adopt a standard if it's actually going to be an open standard. And in fact, I think in the future, X402 will likely accommodate fiat as well, not just crypto and stablecoin mechanisms. And that's because it's far more valuable if there's one standard that everybody uses than if there's 15 competing standards that break interoperability. Like the internet kind of works because no one questions that, hey, you should write your websites in HTML. No one is out here trying to have like proprietary HTML that isn't compatible with Chrome and Safari and all these other things. No one requires you to download your own browser in order to navigate the internet. And so I think that that's how X402 should work as well. Anyone is welcome. Anyone can add their token or their chain to X402. In fact, in most cases, they don't even need to talk to me to do it. It just should work because ultimately it's just a declaration of a flow between a client and a server.
Love that idea. It's permissionless. Standards work well when they're open and not tethering to any specific blockchain or type of currency makes it more adoptable in essence. Maybe we can see it in action. I'll present a little demo video that we have here, and maybe you can tell us what's going on here.
So this is an example of a human paying for some paywalled content using X402. And so they connect the wallet, they click pay now, they confirm in the wallet by signing a message. And then what's happening during that processing time is the X402 transaction is being sent from the client to the server, and then the server is forwarding it to a facilitator who's bringing it on chain. And it's exactly what we walked through in that diagram. And for anyone who's in crypto, this probably isn't that interesting. But if you advance to the next slide, the thing that's interesting is that a client or a program or an agent can navigate that same flow in a standard way using one line of code. And so when you're doing wallet connection, when you're doing payments, when you're doing all these things, there's actually a lot of ways to say how to make a payment. Like you could be signing a message, or you could be broadcasting a transaction and sending the transaction hash. There's all these different, ways to actually make the money move. And so X402, part of the value is that it prescribes the way to make the money move, which means that you can have really clean abstractions. And now if you're building an agent, you just need to wrap your fetch or your Axios, and now it can pay for any arbitrary endpoint.
So we're very much starting to get into this, which is the AI part and like why now. So we've talked about how X402 really fulfills this vision of using the internet as a native payment rail. And we saw this great demo of the crypto use case. It's the standard self-custodial wallet signed transaction case that many of us in crypto are familiar with. And here we're demonstrating that you can actually do this with one line of code. But let's get into the real AI stuff and like why this is important to get right now.
It's a great question. And I think how many tools does your AI have right now, Yuga? Like you have Cursor set up. Like how many MCP integrations do you have with it right now?
Not that many. I mean, probably 2 or 3.
But do you find each one of those is valuable or helps your AI perform better, or is it kind of optional?
I think they're good at very targeted tasks. And I'm still doing the job of gluing them all together.
Yeah. I think that's a correct assessment of where AI largely is right now. And there's kind of 2 things that I'd call it. One is that AI agents to some degree are as good as the tools they have access to. Like if they can't search the web, we've taken for granted that web search is now like a thing that every good like ChatGPT or Claude or all these other like good providers can do. That's actually a tool that they just abstract for you and integrate very cleanly. And right now you need to add each tool to your agent one by one. There's no kind of like discover everything. And then two, your agent is going to want to take actions that aren't necessarily economically incentivized by the person on who's hosting the server that they're interacting with. And so there's a really good Ben Thompson article that I very much agree with. But the crux of it is that AI agents kind of fundamentally break the economic model of the current internet. Like the rough flow of payment capture on the internet is that you as a human consume some content, you view an ad, and then probabilistically sometime in the future that ad has influenced you either directly or subconsciously to purchase a particular good or service. You know, you browse Instagram, you see an ad, you're like, oh, I didn't know I needed that belt, and then you buy the belt. But AI is significantly less susceptible to advertising. And so we need a new economic model that underpins how the internet works, because people still need an incentive to publish content. And so I think micropayments are a great use case of x402 that have not been possible until now because it just costs too much to transmit value. You can't really charge 10 cents to a credit card, but you can absolutely charge 10 cents and transmit via stablecoins. And so this Ben Thompson quote I really like is that this is where Scott's extortion of openness is spot on. A world of one dominant AI making business development deals with a few blessed content creators and scraping the carcass of what remains on the web for everything else is far less interesting than one driven by marketplaces, auctions, and aligned incentives. To get there, however, means realizing the internet's so-called original sin was, in fact, the key to realizing the human web's potential, while the actual mistake would be not building in payments now for the coming agentic web. And what Ben's getting at is that we now have a situation where being able to transmit value programmatically is no longer optional. Otherwise, you're going to end up with kind of like a closed AOLification of the internet, where there's a few anointed people that these big model providers scrape all their data from and cut robust one-to-one business deals with. And everyone else is just going to kind of shrivel and die. And so if you're not in the club, you're not going to have you're not going to make any money. You're not going to have any incentive to publish. It's going to be very boring, and they're going to take all your stuff for free anyway, because they'll just scrape you. And so now with concepts like pay per crawl and pay per use, you have a way of saying like, you can use my stuff and you can feed your agent my stuff, but you have to pay me for it.
Got it. So none of us want to be in a dystopia where AGI has all the content and content creation is no longer an economically viable activity. And by content creation, I don't necessarily mean just like social media, but like news or like all entertainment or all just stuff we read or view. That seems like a pretty dystopian world. So we need an economic model that allows for things like micropayments or usage-based or consumption-based billing. That seems very rational. And the other piece of this I just add is like stablecoins have become a real thing, especially since the passage of the Genius Act, which happened this few months ago, actually. And that's really opened the doors for companies to be able to integrate blockchain natively into their tech stack. And so when you combine the power of stablecoins and permissionlessness of blockchains that the x402 leverages with this new AI-centered internet that we want to prevent from being, again, like AGI just gobbling up everything, but something that like makes sense on ironically a human basis where micropayments are possible. We want to prevent AI from breaking the fundamental economic arrangement of the internet, and that's sort of what x402 attempts to intermediate.
Yeah, it tries to propose a realistic solution to that problem. I think AGI is an AI is like the why now. It's the why there's a chance at solving this like age old problem. Because we kind of like, we solved it well enough for humans, right? You can enter your credit card on the internet and you can get like a payment token from most major providers. And we've made like checkout pretty smooth for humans now. But it's fundamentally, there are no standards for payment. The way that you use Shopify is completely different than the way you use Amazon. What Amazon and Shopify are doing in the backgrounds are completely different. It's just that they're big enough where everyone integrates them. There's no standardization there. And that means that like all that stuff doesn't really work for an AI. And so x402 is really an attempt to solve a very old problem. And, you know, I think the tech is good, but I think the real tailwind behind x402 is the motivating use case of AI agents being an underserved it's a massive market and an underserved actor on the internet. And the great thing is that actually it makes AI better if they can pay small bits for value. And there's a video demo we can show if that helps illustrate this. And so what this demo is me using Claude, and I've given Claude access to the x402 protocol via a wallet. And also x402 has a discovery layer built into it. And so what Claude is able to do is discover things that it can pay for and then pay for them without needing to involve me. And so it sees a bunch of these services and it realizes like, okay, I can go and pay for a bunch of useful tools. Most of these cost like under $1. Is it cool if I go and buy this thing? Can I pay like a couple cents to try this demo endpoint in this case? And what it's doing now is autonomously making the payment without me needing to enter a credit card or link a bank account or anything. And it succeeded in making the payment, and it has access to that paywalled page that we showed in the earlier demo. And why this is cool is because, one, it allows it to pay, you know, a cent to access something that makes its ability to serve me better. You can imagine if it's able to pay a small amount for access to gated content, it can provide me a better answer. But two, it's able to discover the catalog of things that are available across this ecosystem without having to integrate each tool one by one. And so you kind of add support for x402 to an application like Claude, and now you get access to n number of tools rather than 3 tools. And what we've actually seen is there's now, I think, about 80 or 90 tools available in the x402 ecosystem. None of them had to register with Coinbase. They all just, you know, support x402 payments, and it all just works magically because it's an open standard and it composes well.
Yeah, I mean, this notion of content, and in this case, what we're doing is discovering various API endpoints, which actually are just content. They're literally just the HTTP payloads we saw earlier in the talk. So in this example, you're using some sort of theoretical SoundCloud sort of music-based API, and that's allowing this protocol allows you to not just pay for it, but also discover the services that have x402 enabled. Maybe we can take a look at a more concrete / relatable / human example where it's like more about like buying something from a merchant.
So in this example, what we're doing is we're full on shopping. This concept of agentic commerce. And so I'm just telling my agent, hey, buy me a t-shirt in a large to commemorate this this festival that I'm at. And so it can go and discover all of the merch that's available, and it can do a little render this. And if we scroll down, it says, oh, I found a festival t-shirt. That's perfect. And it's enlarged. Let me make the payment. And it can actually autonomously go make the payment without me having to confirm. And I can go and see a receipt that would let me claim the merch from the merch table. And agentic commerce as a whole, I think, leads to like really interesting scenarios where like your AI understands your purchasing history and understands things like your size. I don't need to tell the chat that I'm a large now. I can just say, hey, buy me a t-shirt with like a dog on it, and it'll understand it. And so now I'm actually saying, buy me as much merch as possible. You have a $15 budget. And so it checks to see, does it actually have enough money for a $15 budget? And then it goes and checks, okay, there's a t-shirt that's available that I can afford and a sticker that's available that I can afford, and it can go ask me for confirm of, does that sound like a good cart to you? And I can say that sounds great, and it'll go ahead and pay for everything that it proposed.
So it's really cool that X402 kind of allows for both really specific agent, high frequency, high volume, low value transactions, as well as more human agentic commerce that is really intended for humans as the end user, but it's the agent facilitating these purchases. So it kind of works for any type of payment type.
That's really the power of stablecoins, by the way, just to cut you off.
Yeah, no, please.
That I don't think people realize is that with stablecoins, you can move a tenth of a cent, or you can move $1 billion. And from how much it costs to make that transaction, it doesn't matter. It's the same thing happening on chain. It's just a different value that's being moved.
Totally. I think USDC specifically, for instance, supports up to 6 decimals, I think. It's either 6 or 8, I forget which.
It supports 6 decimals, but what that means is that it has 6 decimals trailing, but you can represent any number, any realistic number.
Yep.
With USDC. Like, I believe the upper bound value of USDC is like several quintillion.
That's quite big. Maybe we'll eventually get there.
With inflation, we might.
At the rate of money printing these days. Cool. 2 more questions. First is kind of a devil's advocate question for you. What do you see as the principal challenges or roadblocks for X402 to get adopted? Or do you see it as an inevitable?
I see it as inevitable that a standard for payments emerges, because AI agents are going to need to programmatically pay each other, and probabilistically filling out a credit card form as an agent doesn't seem tractable to me. In terms of X402 specifically, I think the biggest challenges are acceptance. And so really, payments are a two-sided marketplace. X402 has supply and demand. The supply is all of the servers that I'll accept X402 transactions and X402 payments, regardless of the underlying currency or network. And then the demand is all the people who are willing to pay for X402 services. And so the first 6 months of X402, we've put a lot of effort into boosting the supply side of the market. And now there's like 80 plus different things that you can do in X402. And there's like big providers like FreePick and Firecrawl and Hyperbolic and a bunch of others that have started to accept X402 for their services. I think the funnest example of something you can buy with X402 is that I've seen recently is you send a post request with like an image and a piece of text and a t-shirt size and an address, and you post like $20 and it'll mail you a t-shirt.
That's really cool.
Yeah, and so you can literally be clothed by your AI. And so now there's a good amount of stuff to do. There's like financial data. There's all sorts of stuff in the X402 Bazaar. And so now it's about boosting demand. And so that example of that Claude MCP wallet that I showed is actually a product that CDP is launching that'll allow anybody to use X402 via any MCP compatible chat application. So it'll work with Claude, it'll work with OpenAI, it'll work with Cursor. Your Claude can now just go and pay for stuff on the internet or buy you t-shirts or like generate images using FreePick. But it's this constant, like, eventually, hopefully the demand side pops up a bunch, and then the supply side pops up a bunch, and then the demand side. And then you end up with a network effect where X402 becomes the default thing to both accept and to charge. And so I'm super excited for partners like Cloudflare to come online. We're moving X402 into a foundation in partnership with Cloudflare. And Cloudflare is going to be using X402 for all their pay-per-crawl. And so what that means is that if you're a person who hosts a website using Cloudflare's infrastructure, right, we've all probably seen the "Are you human?" button. You'll be able to say like allow or block or pay instead of just allow or block for AI agents. And that means that you're going to have a ton of x402 usage. That means that there's going to be a ton of incremental value accrued to the creators of that content. And it means that AI agents are going to have more robust context.
That's really awesome. And it sounds like you have a bunch of stuff in the pipeline, including this new foundation that's spinning up. You have a new feature launching, like that Claude demo you pointed out. In terms of what's next, anything else to call out? I think I saw a PR go by where there's a V2 of the protocol being proposed as well.
Yes. So we're working on the V2 of the spec. The V2 of the spec doesn't diverge a ton from the flow we walked through together. There's just, after 6 months of real world usage, a bunch of minor breaking changes that we want to add to really smooth out the rough edges and improve the developer experience. But it's been amazing to get feedback from the community and all of the, honestly, I can barely keep up with responding to all the comments, but people seem to like the V2 so far. So it's been great to build it alongside this amazing community that we've put together.
Super exciting. Why don't we call out where folks can get information about x402 here?
So x402.org is the official website of x402. Check out the GitHub. For now, it lives at github.com/coinbase/x402. There's also a million x402 accounts on X you should follow. Mine is @programmer, and if you want to build applications or you want to build clients for x402, both of the demos that we showed use CDP's embedded wallets and CDP's facilitator, cdp.coinbase.com, for all your building with crypto needs.
Awesome. Well, thank you so much for taking us through x402 today. And for everyone listening, thanks for listening in, and follow us at Coinbase Dev. Thanks so much. Lead the world's transition on chain by building with Coinbase Developer Platform. Visit us at cdp.coinbase.com. Follow us on X at Coinbase Dev, and be sure to leave us a review on your favorite podcast app.